Seeing it right? Oh,
yeah.
Just forget this. All right, I'd like to introduce the next speaker, Trang, with his topic, which is titled "Learning to Adapt Neural Models with Limited Human Supervision in Natural Language Processing." So please kindly unmute yourself and share your screen.
Okay. Thank you. Yeah, thank you for the introduction. So can you see my screen? Yeah. Good morning, everyone. So my name is Thuy-Trang, and I will present my PhD study with the title "Learning to Adapt with Neural Models with Limited Human Supervision in Natural Language Processing." So my supervisor is Reza Farib and Jin Pung from Monash University. So the motivation of my thesis is from on the fact that deep learning relies on supervised learning on large amount of label data. For example, in machine translation task, for machine translation tasks, the neural MD can only outperform the phrase-based MD, which is a classic statistical machine translation approach, which is popular before deep learning era, when we have more than 1 million training blocks. And even when we're comparing different neural approaches, we can only see the significant difference when having enough data. For example, in this block, we have the natural language inference task, which is the 3 classification tasks to predict whether 2 sentences internal, contradict, or neutral. So when we compare to contextualized language model, which have shown very specific on this task, which are bird and animal, then the retrained bird doesn't make any difference to the random initialized bird or animal if we only have a few hundred samples. And furthermore, like neural network are also critical and sensitive with the slight changes of the distribution on and the task specific. But we cannot always collect the label data because it's very challenging and costly to obtain, especially if we just to collect data in some specialized domains. So therefore, learning with limited labels, the limited human supervision is still remain a challenge in deep learning. But for us as humans, learning from scratch, for every single task is constantly how human learn and solve problems. And because as humans, we often use the past experience and knowledge to quickly learn the new task. So that is motivate my thesis that maybe deep learning model can also take advantage of prior knowledge also called as inductive bias to accelerate the learning of new tasks or concepts. So what is the type of the source of inductive bias? So inductive bias can be in form of the human expertise. So it can reflect of the choice of the model architecture or the choosing of the feature engineering. It can also come from the unlabeled data. This is we can make use of the available text in Wikipedia, from the internet, on the news media as well. And the inductive bias can also from the related task. So if we have any task where we only have abundant of labeled data, then we can use that to train our model and then transfer it to our task of interest. As the focus of this work is on learning with the less human supervision, so I will mainly focus on the inductive bias come from the unlabeled data and the related tasks. So for that is come from that, and that is something from the one of motivation scenario for my research, which is the domain adaptation. For example, if I have I want to learn a sentiment analysis for a customer review, and where I only on kitchen appliance, but I don't have any label data. So what can we do? So if I have the label data on the books domain, then I can train the models on the book format and then transfer it to the kitchen appliance. Because the review can share the same structure and the certain adjective for about the product qualities. Here we can see that like the good and the terrible have the same meaning in both books and kitchen domains. So additionally, we can also use the generic text which are easily crawled from the news or Wikipedia on the internet to learn the presentation and to boost the performance of the classifiers. So on the described above approach is based on the idea of transfer the inherent property of knowledge related to a class of interest. However, the main challenge is that the performance may deteriorate potentially on the presence of domain mismatch. So that will be our main objective of this work. It's led to the first scenario on the first problem that my lesson is for solving is the use of unlabeled data. So because we have the massive amount of unlabeled data available, and however it's noisy and cover a wide range of topics, and using the right data is critical to achieve the performance specialized domain. So the question is, how do we intelligently select the relevant text which can be used to accelerate adaptation of the models? And to do that, we propose a method that would select the data with the pre-trained related models. It is based from the observation that the presentation learned by a pre-trained language model can be clustered by domains without supervision. And so in this figure, we can show that like the presentation of different data of different domains is clustered well on the presentation space. And so this observation allows us to learn to train a classifier to learn the domain boundary, and we can use that to select the corresponding unlabeled data that belong to a specialized domain. However, if you want to use that for the cross-lingual data selection, then the retrained multilingual pre-trained language model may not align well. So one domain classifier working for English may cannot transfer well for Arabic or French, for example. So to enable cross-lingual transfer, the center presentation should be aligned while still reserving the domain characteristics. So to do that, we propose a method to first align the presentation using the contrastive learning, using some initial small parallel corpus, and then we to avoid the presentation collapse when we perform the contrastive learning. We first clustering the input with using k-means, and then align the presentation. This cross-lingual method we use that to evaluate on identity by where we will select additional English for generic pools of data, and then we compare on several languages, especially French and Arabic, and our method, our data selection method can significantly push the perform on the blue star on the identity task. And for the TSN visualization of the French and English presentation before and after the adaptive layer that we use to align the presentation, is so that like now the French and English presentation is aligned better in the presentation space. So far we must only discuss how we can use the unlabeled data to query the relevant data for the upstream task. So now I will discuss how we can use the related task. So for that, we propose using the domain adaptation, the self-supervision. So the self-supervision is is the main idea behind the pre-trained then fine-tuning paradigm that is popularized by Bird. So the so in this diagram, we will use the successful learning to pre-train the presentation. Then that is often used in we have Bird GPT, for example, and then that's and then we will fine-tune on the downstream task with the task learning here. So with the domain adaptation, the self-supervision, then we introduce domain adaptation step between the pre-train and then fine-tuning paradigm, where the general feature presentation will be further adapt via self-supervision on the combination of both source and the target domain data before the task learning. So notice that because the domain adaptation, we also load the supervision, so we don't need to have any label data for that. Yeah, and this can have to bridge the gap between the source domain and the target task domain. So we propose an adversarially trained mass language model so that we can effectively to perform self-training on a super domain adaptation. And the idea is based on that the adaptation methods should stand on the token that have semantic or syntactic shift. So the training method is based on an adversarial principle. So that instead of in the self-supervised learning in Bird, the mass language is trained with the mass language model objective, and where we randomly mask some tokens in the data. So we introduce our teacher, which is a puzzle generator, will generate the participation, the mass sentence, which such that it's really difficult for the mass language model to be nice. And we evaluate that for consumer domain adaptation to adapt from the kernel 2003, which is in on news domain, to the various domain, including Twitter, which is in the not financial, and the other four is the biomedical domain. So our method with the adversarials is better than the random masking or BOS masking or the masking based on the entropy or the uncertainty. So in conclusion, that my thesis proposed several methods so that we can transfer the prior knowledge to improve the practice class where we have a limited label data. So mainly we have a cross-lingual data selection to select useful unlabeled data for super domain adaptation of NMT, and then domain adaptation for self-supervision. Yeah, self-supervision. Yeah. Thank you for your attention.
Thank you very much, Trang, for the amazing talk. I think first I'll ask people who are on Zoom. Again, I'll just give probably a couple of seconds. If you have any questions, please pop in the chat, or you could unmute yourself and ask a question or feedback or suggestion. That awkward Zoom silence. We may never know. Yeah, I'm just checking if there's a chat box. If there's, oops, I accidentally hit the wrong button. Any questions while we wait for the, hopefully it's question Zoom. Any questions from the floor? Nope. I'll try to ask one quick question. Trang, you mentioned about like cross-lingual. Did you notice, is that the case where European-based languages, are there differences, for instance, like Asian languages against on European languages? Like what have you noticed on the cross-lingual aspects of it?
I mean, for the okay, yeah, probably I haven't talking what I mean by cross-lingual data selection. That I mean usually when people working on the data selection, they are working on the same language. For example, like if you have some initial English data, then you will select from more English data. You have French, you select more French data. So what I mean by cross-lingual data selection is that now, because in the translation task, we should have a pair of data for source task and for source language and the like language. So, like in one of my experiments is on English and Arabic. So where I only have English, now I want to, I only have Arabic. Now I want to select the data of other languages. So because it's English Arabic, so we can select more Arabic based on the English data set that we have. So that's what I mean by cross-lingual. And to do that, because it needs to work on in that to transfer all the knowledge on English to Arabic or vice versa. So we need to ensure that like the presentation of English and sentence and Arabic sentence are aligned.
All right, thank you. And I think I can take, there's one more question from Stefan. Right.
Yeah. Sorry, just a question on the transfer. How come you have a difference between English to Arabic and Arabic to English, and where does this difference come from? There is a transfer that is higher in my recollection of the data from English to Arabic and lower to Arabic to English.
I would say like the difference here is that like because why we do need the alignment is because like when for example, it was training on both English data and Arabic data. Actually they on for the 100 languages, but this is on monolingual data. So that's why the sentence data, the sentence on the embeddings of English and Arabic and not actually aligned because we don't have any bilingual or parallel signals when we training. So that's why the presentation of a word for English with its Arabic translation maybe not aligned yet. So that's why like one sentence is English sentence and the Arabic sentence maybe not nearby to each other in the real multilingual semantic space. So is it answer your question?
Perfect. Thank you so much.
All right. Thank you very much, Trang. Round of applause to Trang, please. And